So in this lesson, we're going to go over the properties of special parallelograms. So first of all, I want to go over and review the properties of parallelograms. So when we talk about the properties of parallelograms, we have that opposite sides are parallel. That's what these symbols, these arrows on the side mean. Then we also have that both pairs of opposite sides are congruent. We have that both pairs of opposite angles are congruent. Then we have that diagonals bisect each other. And then we have that consecutive angles are supplementary. So if I was to tell y'all this was 80 degrees, then we would know that this is 100 degrees and this is 100 degrees. So those are our properties that we know about parallelograms. And all of those properties apply to our special parallelograms. So today we're going to prove and apply the properties of rectangles, rhombuses, and squares, and we're going to use those properties to solve problems. So our vocab obviously today is rectangle, rhombus, and square. So the definition of a rectangle is a quadrilateral with 4 right angles. So you should write that down. And then remember again that if quadrilateral is rectangle, then it's a parallelogram. So all those properties we just talked about are true. Now the new property today that we're going to go over is that when we have a rectangle, its diagonals are congruent. Well, so let's talk about what that means. Obviously this is GJ right here. GJ is congruent to HK. Well, that's true, but that we also still know that the diagonals bisect each other. So if the diagonals bisect each other, that means we know that let's go ahead and put a letter here, HE is congruent to JE, is congruent to KE, is congruent to GE. So that's just another thing that we know because the diagonals are congruent and they bisect each other. All right, so now let's work some properties. It says in number 1, a woodworker constructs a rectangular picture frame so that JK is 50 centimeters and JL is 86. So I'm going to go ahead and label JK over here 50 centimeters. And it tells me that JL, that's this diagonal right here, is 86 centimeters. So, and it tells us to find HM. So we're looking for HM from here to here. Well, what we know is that KM and JL are congruent. KM is a diagonal and JL is a diagonal, and those diagonals are congruent because this is a rectangle. So we can say that KM is 86 as well. So if we're looking for HM, we should know that these two parts of that diagonal are congruent because KM is being bisected by JL. So we can take half of KM, and that is HM. So we're going to take half of the 86, and that's 43. All right, so the next one, number 2, says the rectangular gate has diagonal braces. Find HJ and HK. Again, we know that opposite sides are congruent. And the other thing that we know is that these diagonals here are congruent as well, and that they bisect one another. That means that each of these is going to be the same length. We talked about this a second ago. So that means they're all 30.8. So we know that HK is congruent to GK, so it's 48. And we know that HK is congruent to JG, and JL is congruent to LG, so JL is equal to LG. That means that when we're looking for JG, it's going to be 2 times JL. So 2 times 30.8 is 61.6. And that's because each of these would have been 30.8 and 30.8. When we add those two together or multiply it by 2, we get 61.6. All right, number 3, it says if RT is equal to 5x minus 14 and US is equal to 2x plus 10, find VT. So let's look at RT first. RT is a diagonal and US is a diagonal. Again, we know this is a rectangle, so the diagonals would be congruent. So we're going to set RT equal to US. We're going to plug our equations in. We're going to subtract the 2x from the 5x and add the 14 to the 10. That's going to give us 3x is equal to 24. Going to divide both sides by 3. So x is equal to 8. Now I'm going to remind you again that this would be an answer choice on a test or a quiz if it was a multiple choice test, but that's not what the question's asking us for. So now my question for you is, if I'm trying to find VT, which is from our center here out to T, then what would I do first? So if it were me, I'd find RT and then divide that by 2 because VT, again, remember these parts right here are congruent, right? So VT is equal to half of RT. So that's exactly what we're going to do. We're going to do 5 times 8, that's 40, minus 14, that's 26, and half of 26 is 13. All right, now, number 4. If VW is right here, 9x minus 11, and SU, that's this whole thing here from here to here. So if it says VW is 9x minus 11, then that means VWT is 9x minus 11, right? So we know that the diagonals are congruent. So VT, by the way, the whole thing here, this whole thing from here to here is 2 times VW. So, and VT is equal to SU. So we're going to do 2 times 9x minus 11, and that equals 16x minus 12. So that's 2 times 9x is 18x. 2 times negative 11 is negative 22. Then we're going to subtract 16x from 18x. That gives us 2x. We're going to add 22 to negative 12. That gives us 10. And then when we divide 2 into 10, that gives us x equals 5. Now, the next part says find WT. Well, I've already labeled WT 9x minus 11. So we're just plugging 5 in there. So 9 times 5 is 45. Minus 11 is 34. All right. Yeah. Okay. So number 5. So number 5, first thing I want to ask you is, what kind of shape is this again? This is a rectangle. What are all the angles in a rectangle? They're 90 degrees. So we know that this angle down here is 90 degrees. So that's how we could solve for our x. Now let's look and see what it's asking us to find. This problem is asking us to find JHI. JHI is this angle up here. And once we find our x, these two should be congruent to each other because they're alternate interior angles. But the first thing we have to do is find x. So let's find x by adding those two angles together and setting by the angle addition postulate and setting them equal to 90. 3x plus 12x is 15x. 12 minus 17 is minus 15. We're going to add that 15 to both sides. It's going to give us 105. Going to divide 15 into 105, and so x is equal to 7. So now we know, because we already talked about this, that these two angles, the angle down here with this arc, this angle right here, and this angle up here, are congruent. So that means I can just solve for the 3x plus 2. So 3 times 7 is 21, plus 2 is 23. All right, number 6. This one says to find the measure of angle BCE. So let's see where BCE is. BCE is this angle right here. So the first thing that I noticed, though, is that the two angles that I'm given here are alternate interior angles. That means we should be able to set those angles equal to each other and solve for x. So 11x minus 7x is 4x, and 5 plus 3 is 8. Divide 4 into 8, that's 2. So now we can plug this 2 into this equation right here. And you should be able to see that 2 times 11 is 22, minus 3 is 19. And when we add these two angles together, I want to show you something. When we add these two angles right here together, again, that's a right angle down there because this is a rectangle. So when we add angle BCE to angle DCE, it equals 90. So when we do that, we're going to get BCE plus 19 equals 90. We're going to subtract the 19 from both sides. So that means the measure of BCE is 71 degrees. So the next special quadrilateral we're going to talk about is a rhombus. And a rhombus is a quadrilateral with 4 congruent sides. Also recall that a rhombus is still a parallelogram. We said that all 3 of these special parallelograms are parallelograms. And also I want to talk to you about this in the middle one. So this one says that if a parallelogram is a rhombus, then its diagonals are perpendicular. Well, let's talk about, we've got this one is a right angle, right? So if that one's a right angle, the one opposite has to be a right angle because they're vertical angles. And the one next to it has to be a right angle because it's a linear pair, and 180 minus 90 is 90. And this one over here, again, has to be a right angle because it's a vertical angle to the one. So what I want y'all to notice is that all four of these, and this is always going to be true of rhombuses, all four angles on the inside of there are going to be right angles. Then this property over here says if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. So let's talk about if we said that R was 100 degrees and that TR bisects angle R, then obviously each of these would be 50 and 50, right? Now let's talk about this angle S. We said that angle R was 100, so S would have to be 80 because remember, consecutive angles are supplementary, right? So then again, QS bisects the 80 degrees, so this would be 40 and this would be 40. So when we have diagonals in a rhombus, they bisect the angles. So we're going to go ahead and use these properties now with some problems. So the first one, JK equals 12 and JN equals 7. So we know that this is a rhombus. So all four sides are congruent. So that means this is 12 and this is 12 and this is 12 and this is 12, right? We also know that JN is 7, right? So if JN is 7 and MK bisects JL, then we also know that NL is 7. So now we can go ahead and fill in these first two blanks, right? Because we know that all of those sides are the same, JM is 12. And because we know that NL and JN are congruent, NL is equal to 7, then JL is equal to JN plus NL. So we do 7 plus 7. That's 14. So this first blank was 12 and the second blank was 14. Now I want to talk to you about the Pythagorean theorem. So you guys probably learned a squared plus b squared equals c squared. Well, that means leg squared plus leg squared equals the hypotenuse squared. So let's talk about what we have in here. Remember I said when it is a rhombus that all four angles in there are right angles. So let's see what it's asking us about next. It's asking us about MN over here. So let's find MN. We got MN right here. And notice that we now have a right triangle. Recall that the side opposite the right angle is the hypotenuse. So what we're going to do is we're going to do a leg squared plus a leg squared, and we're going to set it equal to the hypotenuse squared. So we're going to do NL, that's this 7 right here, plus MN, which we don't know, squared, and we're going to set that equal to ML squared, which is our hypotenuse. So when we do this, we get 7 squared because we're just plugging in the 7 right here. And then MN we don't know, and then we've got 12 here. This again is our hypotenuse. So 7 squared is 49, and 12 squared is 144. We would then subtract the 49 from both sides, and we would get 95. Now recall, if I'm looking for M and I have if I'm looking for MN and I have MN squared, I have to take the square root of both sides of this to get rid of that square right there. So that's exactly what I'm going to do. So when I do that, I'm going to get the MN is equal to 9.75. So that's our MN. So we're going to go ahead and put it up here, 9.75. So I'm going to go ahead and put it in here in my drawing too, because this is 9.75 right here, which also means this right here is congruent to this. So this is also 9.75. So when I'm looking now for MK, I can just do 2 times MN. MK is equal to 2 times MN. So 2 times 9.75 is 19.5. Again, we're using a lot of our properties here that we've learned prior to today. So number 8 says EF is 23. Again, this is a rhombus, so we know that EF is 23, FG is 23, GD is 23, and DE is 23. It also tells us that DF from here to here is 40. So we know that the diagonals bisect each other. That means DH would be 20 and HF would be 20. So now we've got a couple of answers we can go ahead and fill up here. 23 here and 20 here, right? All right, so now what we need to find again, recall that all 4 of these angles are right angles. And we are looking again for GH. So let's find GH in our drawing. It's right here. we again have a right triangle. And we have our hypotenuse, that's 23, it's opposite the right angle, and we have one leg. So once again, we are going to do GH squared plus HF squared equals GF squared. Going to plug in our values. We're going to get 400 for 20 squared and 529 for 23 squared. We're going to go ahead and subtract the 400 from both sides. Now again, when we get this GH squared right here, we have to take a square root of both sides here to get rid of that square. When we do that, we get that GH is equal to 11.4. So GH is 11.4. Then it's asking us for GE. So GH is 11.4, and we know that if GH is 11.4, then it's equal to HE, which once again, we can either do 11.4 plus 11.4, or we can do 2 times 11.4 and get 22.8. Number 9. So number 9 says RT equals 22 and US equals 18. So if RT, the whole thing, equals 22, then we're going to divide that by 2 to get 11 here and 11 here. Same way with this US, it's the whole diagonal, so we're going to divide that by 2. That means this would be 9 here, and this would be 9 here. And once again, we have our right angles in here. So this time, we have that VT is 9, right? No, VT was 11, sorry. And UV was 9. Then we have RS and ST that we're looking for. Now, what we do know also is that all of these sides are congruent. So if we can find one, we can find all of them. So let's find out where RS is. So when we look at RS, it's this side out here. So here again, we have a right triangle. Hopefully all of y'all see that. So we're going to do this time RV squared plus VS squared is equal to RS squared. Let me go ahead and put all this up there, how we got all those answers. RV squared plus VS squared is equal to RS squared. This time we have these two values, 11 squared and 9 squared. So we're going to do 121 plus 81, that's 202. And RS squared is equal to 202. So we're going to take square root of both sides again. So RS is equal to 14.2. Well, if RS is equal to 14.2, then obviously ST has to be equal to 14.2. Because all our sides are congruent because it's a rhombus. All right, let's look at number 10. So number 10, this one's a little bit different. Now, let's just start with the center, because we know, because this is a rhombus, that all 4 of these angles have to be right angles, right? So let's go ahead and put down here for the measure of angle 8 that it's 90 degrees. Then let's talk about what else we know. We know that the diagonals bisect the angles. So that means angle 3 down here, if this part right here is 38, then this part right here has to be 38, right? Then we can talk about what is 38 plus 38. We're going to do that angle addition postulate. That would be 76 degrees. Now we know that this is a parallelogram. A rhombus is a parallelogram, so opposite angles are the same. And once again, we know that these angles are being bisected, so this is 38 here, and this is 38 here. Now, another property that we know is that consecutive angles in a parallelogram are supplementary. So to get this angle out here, we're just going to go 180 minus 76. That's 104. So we know that the whole angle over here is 104, which means when we're looking for it being bisected, 104 divided by 2 is 52. So 1 would be 52 and 2 would be 52. Once again, opposite angles are congruent in a parallelogram, and it's being bisected, so we got 52 here and 52 here. So now that we've finished our drawing, we can just go ahead and write the values in. So this angle 1 was 52, angle 2 was 52, angle 3 was 38, angle 4 was 38, angle 5 was 38, angle 6 was 52, and angle 7 was 52. So remember, all the angles in the center of a rhombus are right angles, which means they're all 90 degrees, and all the angles at the vertices are being bisected by the diagonals. So number 11 says TVWX is a rhombus, and find TV, find the measure of angle VTZ. So the first thing we know is that all these sides are congruent because it is a rhombus. So that means that we can set those opposite sides equal to each other. So that would mean XT is equal to WV. And so we do 3B plus 4 is equal to 13B minus 9. We're going to subtract, I did this opposite, but it should have been, either way, it doesn't matter. It would be negative 10B minus is equal to minus 13. And then we're going to divide by 10, and so that's going to give us 1.3. So then we're going to plug that back in. And honestly, it doesn't matter which side we plug it back into. I'm going to plug it into the XT side because XT is equal to TV, so I'm going to multiply 3 times 1.3, that's 3.9, and add 3 to that, so that's 7.9. So that's our first answer that's asking for us up here to find TV. Then the next thing it's asking me is to find the measure of VTZ. Well, VTZ is this angle right here. Well, to do that, first we should notice that these two angles are congruent because diagonals bisect that big angle T, right? So those two angles will be equal to each other. Well, the problem is I can't solve for 5A. I can't solve for the A right now because I don't have enough information from that particular equation. However, remember once again that all of our angles in the center here are right angles, right? So that means we can set this equation right here equal to 90, right? So that's exactly what we're going to do to solve for A, and then we're going to plug our A back in up there. So 90 is equal to 4A plus 20. Subtract 20 from both sides. That would be 70 is equal to 14A. Then divide both sides by 14, so A is equal to 5. Now we know that these two angles are congruent, so we then can actually say that the measure of VTZ is equal to 5A minus 5. So 5 times 5 is 25, minus 5 is 20 degrees. So that was our answer up here. And recall that if this was 20, then this one up here was 20. The whole angle would be 40. And if T was 40, then that means the X would be 180 minus 40, which would be 140. And then this angle right here would be 140 divided by 2. That would be 70. And this angle right here would be 70. So we can actually find all the angles in this rhombus with what we were given in this problem. And there will be problems like this on the quiz and the test and on the homework. All right, so number 12 says GDF is a rhombus, find CD. Once again, we know that all of our sides are congruent, so we can then set some sides equal to each other to solve for CD. So when we do that, we subtract 3A from 5A, that gives us 2A. Divide 2 into 17, that's 8.5. Then we're going to plug that 8.5 back in. Doesn't matter which one we plug it in, but 5 times 8.5 is a little bit easier. So that's obviously going to be CD. CD is equal to 42.5. Now let's talk about this other part. We're looking for the measure of GCH. And let's look and see what we have. We have GCD. GCD is all of this, and that would be B plus 3. That's for the whole angle, right? And then we also have, let's do this in a different color so we can see it, CDF. So CDF is all of this angle up here. So that's going to be 6B minus 40. Well, what do we know about consecutive angles? When we add C to D, they're supplementary, right? So that's exactly what we're going to do to solve for B. We're going to add those two together, set them equal to 180. That gives us 7B minus 37, that's equals 180. We're going to add 37 to both sides. That gives us 217. When we divide 7 into 217, we get 31. Now, what we want to do is we want to find what it's asking us for. Now it's asking us to find GCH. So GCH is that part of the angle. So we have the measure of the whole thing. So if we're trying to find GCD, and then we'll divide it by 2. So GCH is equal to 1/2 GCD. So we're going to do 31 plus 3. That's going to give us 34, and we're going to take half of 34. So GCH is 17 degrees. All right, now let's talk about a square. Squares are quadrilateral with 4 right angles and 4 congruent sides. So here's the deal. A square has all the properties we've learned. properties of parallelogram, properties of rectangle, properties of rhombus. So let's talk about what those are. Parallelogram, opposite sides are congruent, opposite angles are congruent, diagonals bisect each other, and consecutive angles are supplementary. Rectangle has 4 right angles, and its diagonals are congruent. A rhombus has 4 congruent sides. Its diagonals are perpendicular, and its diagonals bisect the vertices of the rhombus. So let's look at DG up here in HF and then solve for the rest of these. So this is what we know. Again, this is a square. All 4 sides are congruent. We have 4 angles here at our vertices. Those are all right angles. And we also know that all these angles inside here are right angles because a square is also a rhombus. So DG is 5. So that means all of these sides out here are 5, right? And then it says HF is 3. HF is 3. So HG is 3, so DH is 3, so HE is 3. So when we were talking about DE, and by the way, these numbers wouldn't be accurate in an actual problem, but this is just for illustration purposes. So let's talk about DE. So DE was 3. Sorry, DE. Where's DE? Oh, no, D is 5 because it's a side. GF was 5 because it's a side. Then we got DH is part of a diagonal, so that's going to be 3. DF is the whole diagonal, so that's going to be 6, 3 plus 3. And GE is also going to be 6 because it's 3 plus 3. Then we have angle EFG. So let's find angle EFG. We do this in a different color so we can find it. Angle EFG. EFG, that would be 90 degrees, right? Then we have GDH. GDH is this one. Well, we know that our diagonals bisect the angles. Well, if the whole thing is 90 and we divide that by 2, then that means each parts of these up here are 45 and 45. And that's going to be true throughout the whole square. So this angle is going to be 45 degrees. And then we got FED. FED is another full angle out here, right? FED, so that's going to be another 90-degree angle. FEG, sorry, I did that wrong, y'all. FEG, oh, sorry. FEG is this one down here. So that's the angle we're talking about. So it's another 45-degree angle. And then we got DHG. DHG. And remember, all these angles in here are 90 degrees, right? So that's the one we were talking about there. All right, let's look at the next one. Let's see if you guys can do this one by yourself and then come back to me when you're done. So it says WY is 5.6. So if we divide this by 2, that's going to give each of our parts 2.8 and 2.8, which means all of these are 2.8. If you remember, a square is a rectangle. A rectangle's diagonals are congruent and they bisect each other, right? Then we got WZ is 4, and all of these sides are congruent, right? Because this is a square. We know that. We also know that all these angles are right angles, and our angles in the center are all right angles, right? So when we start going through this one, and remember, those diagonals bisect those angles. So if we start talking about parts of those angles out there, then we're going to talk about 45-degree angles. So ZY was 4, WX was 4, RY was 2.8, ZX was the whole thing. That was the whole diagonal, so it's 5.6, 2.8 plus 2.8, or you just remember that the diagonals are congruent. Then WRX is 90 degrees. So let's talk about where WRX is. WRX was this angle in here, and again, remember, those are perpendicular. The diagonals are perpendicular. Angle Y out there, this one down here, is 90 degrees, and then XZW. XZW, again, would be this angle down here bisected, right? So 90 degrees divided by 2 would be 45. So let's answer these next questions. It says, which quadrilaterals always have diagonals that are congruent? Well, by our properties, those are rectangles. Now remember, a rectangle has a diagonal that's congruent, but a square is also a rectangle because it has 4 right angles. So it's going to be rectangles and squares here. Number 16 says which quadrilaterals always have consecutive angles that are supplementary. Well, parallelograms, that was our rule with a parallelogram. Well, a rectangle, a rhombus, and a square are all parallelograms, so that would include all of them. Our next one, number 17, says which quadrilaterals always have diagonals that are perpendicular. If you recall, a rhombus has diagonals that are perpendicular, and a square also is a rhombus because it has 4 congruent sides. So this time it's a rhombus and a square. Number 18 says which quadrilaterals always have diagonals that bisect each other. Recall that this is a rule of a parallelogram. So that means it's going to apply again to the rectangle, the rhombus, and the square because all of them are parallelograms. Number 19 says which quadrilaterals always have opposite angles that are congruent. That was again another property that had to do with parallelograms, so it's going to apply to the rectangle, the rhombus, and the square. Number 20, which quadrilaterals always have diagonals that bisect opposite angles. If you recall, that is a rule that applies to a rhombus, and a square is a rhombus because a rhombus has 4 congruent sides, and so does a square. So our next two, the last one says name the quadrilateral based on only the given information. So if all 4 sides are congruent and the diagonals are not congruent, this is a rhombus. B says opposite sides are congruent and diagonals are congruent. So opposite sides are congruent, that would be all of them, but the diagonals are only congruent in rectangles. So this would have to be a rectangle and a square because a square is a rectangle. This next one over here, name a quadrilateral based on only the given information. Again, all 4 sides are congruent. That would have to be rhombus and square. Now, which one of those has the diagonals that are congruent as well? That would just be the square because that is the definition of a rectangle. So remember, a square is both a rhombus and a rectangle. Then our last one, opposite sides are congruent. That would be all of them. But then it says the diagonals are not congruent. So that would not include a square and a rectangle. So this would be a parallelogram and a rhombus.